Bienvenue. Welcome to Space Codesign's online broadcast of our presentation from DAC 2014. We are doing this for the benefit of those who weren't able to attend the 51st Design Automation Conference, but if you did, here's a refresher for you. Our presentation will be on ESL and hardware-software co-design for rapid development of SoC embedded systems. First, the challenges to the electronics industry that we want to help solve. Electronic gadgets like smartphones, GPS, and tablets have quickly become a part of our lives, and it's hard to imagine living without them. But take a moment to consider that these devices are complex systems of hardware and software that must work well together, an ever-growing challenge to the electronics firms who create them. Short product life cycles put severe limits on development time and cost, so these companies are hitting the wall on productivity. Errors and the need for re-engineering are costly in both money and time. Also, said marketplace changes can force quick strategic shifts. Just a few years ago, netbooks were the wave of the future. Then tablets came along. Our solution, called Space Studio, is the next generation of ESL, or Electronic System Level, design technology. Space Studio is one of the few electronics design platforms that can take you through all three stages of algorithm, architecture, and implementation. Its focus is not only on hardware design, as in the first generation platforms, but also software. In hardware-software co-design supported by automation to retarget the same functions in your embedded application for hardware or software without recoding. While Space Studio is focused on system architects, it provides a platform to interact with hardware designers and software developers. To appreciate the benefits of using Space Studio, we should first look at the traditional design flow. This methodology involves hardware and software development taking place on parallel tracks. The hardware platform is designed first, and software development doesn't start until a minimum viable hardware design is available to program. Integration takes place weeks, even months later, and that is a risky step. Software often needs to be modified to run on the resulting hardware. Worse, hardware reengineering may be required, putting a long time loop that extends and delays the project. Virtual prototyping and improvements in hardware prototyping have improved the speed of development projects, but not the approach. The risks and pitfalls remain the same. Henry Ford once said that if he had asked his customers what they wanted, they would have said faster horses. But Ford and other automotive pioneers introduced a new paradigm to transportation. And that's what we do in Space Studio with an agile workflow. Space Codesign supports simultaneous development of hardware and software. This hardware-software co-design approach is supported by automation to retarget the same functions in your embedded application for hardware or software without recoding. This enables an agile design flow as you rapidly determine the hardware-software partitioning that is optimal for your quality of results QOR goals, performance, power, size, etc. Integration is immediate, and problem detection happens early in your engineering work. Space Studio supports models with different levels of timing detail according to standard definitions. At the algorithm level, models are untimed or loosely timed for fast simulation to validate the behavior of the functional specification. Then at the architectural level, with more details on processors, interconnects, peripherals, and memories, more timing information is required. RTL is not out of the picture, only that performing system-level design can narrow down to an optimal design faster than starting at RTL, which is the norm at present. A word about the processor models in our design architecture exploration. For ARM, we support the Cortex-A9 dual MP core using ARM fast models and have a recipe to integrate others in the future, such as the Cortex-M or R. We also support the QEMU modeling technology, which can be configured into different processor architectures, including ARM, PowerPC, and Intel. And of course, we're also assessing other sources of models and their technologies. So the advantages and benefits of using Space Studio for your embedded system design are that rapid system design comes from the breadth and speed of ESL technology, along with innovation that supports hardware-software co-design by retargeting functions in your application for hardware or for software without recoding. For each of your candidates during design space explorations, Space Studio features non-intrusive monitoring that collects a data log of all transactions in their simulation for use in performance analysis. For other evaluations like power and silicon resource estimation, that can be done by calling industry standard tools, such as those provided by Xilinx if targeting their FPGA programmable devices. For silicon implementation down to the chip, Space Studio can support FPGA flows at present. That is useful for physical prototyping alongside virtual prototyping, or going to final release if your product will include FPGAs. For now, with ASIC development, the virtual prototype can be used to guide RTL implementation after this physical validation. In these pictures, we will describe how automation supporting hardware-software partitioning appears to the Space Studio user. We have mentioned that a key innovation in Space Studio allows you to target the same function in your application for either hardware or software implementation without recoding. In the user experience, this is reflected by a drag-and-drop mechanism. Here we show a motion JPEG application implemented as all software in the before picture on the left. This MJPEG is composed of 5 tasks on an ARM Cortex-A9 dual-core processor with 2 functions on one CPU and 3 on the other. If this design candidate is not running fast enough, we can change the hardware-software partition to speed it up. For example, we can select the IDCT inverse discrete cosine transform from the second CPU, drag it to the AXI channel in the design tree hierarchy, and drop it. Then in the after picture on the right, the IDCT is now a hardware coprocessor that will be in silicon. Run a simulation on the new candidate and do performance analysis. An overall embedded SoC design flow with Space Studio is illustrated here. The design process starts with a C++ function for your application, or specification for your application. It enters Space Studio as a multitask functional specification or algorithm whose behavior is validated in our ELIX module. The working algorithm is then mapped into specific architectures involving processors, interconnects, peripherals, memories, etc. in our SimTech module, where design exploration is carried out until you converge on an optimal hardware-software partition that meets your specifications, such as performance and power. Then, with a promising design candidate, our implementation manager GenX will guide it through co-synthesis, the hardware implementation by mapping to libraries or individual reusable IP, or put it through high-level synthesis. And the software implementation is done by cross-compiling executables for the specific processors. One specific flow that Space Studio can run out of the box is in a Xilinx ecosystem, working as a design creation front end for their Vivado tool suite and targeting their flagship Zinc platform. Space Codesign Space Studio technology works in an ecosystem of leading technologies and standards for embedded electronics design. For processor models, we currently support ARM fast models and QEMU, and are looking at other sources. Operating systems supported include embedded Linux and Micrium. Standards supported include IEEE, System C, TLM2, and IPexact. For high-level synthesis, we support Forte Synthesizer and Xilinx's Vivado HLS, among others. For FPGA, we serve as a system-level design creation front-end to the Xilinx flow, which should be adaptable to other technologies as well. So thank you very much for viewing our broadcast today. We hope you find it interesting enough and it makes you curious to contact us. Please contact us at www.spacecodesign.com or follow us on Twitter and LinkedIn. Thank you very much. Merci beaucoup.